Okay, so in this lecture, we're going to go over algebra. So first we're going to do step by step. First we're going to start with the basics. Then we're going to go into exponents. And then we're going to go into simplifying, factoring, log, rhythms, polynomials, linear equations, and finally quadratic equations. So these 7 topics right here should, be enough for you to understand the foundations of algebra, and with that, the world's your oyster. So let's get started with topic 1, basics. So algebra is basically you could consider it sort of like a game, right? Like one of those puzzles and stuff, that you tend to solve and have to think about. So for instance, when you think of regular math, 3 minus 2 is equal to 1. But what if I did not give you this number? What if it was just this? Just a blank, which we'll denote with various letters. So let's scratch this out for now, and let's just use an x minus 2 equals 1. Right? So this is kind of a mystery. We're trying to figure out, well, what can we subtract to get 1? Right? So you can do a lot of things. You can, trial and error is one. Right? You could say, okay, what if I plug in 1? Right? So 2 is equal to minus 1. So no, that's not it. Well, what if I plug in a 2? It's 2 equals 0. So that's not it. 3 minus 2 equals 1. That's it. But this is a very simple example. Right? And in the real world, you're going to have something crazy like this to the y power, plus 1 over square root of x to the y power, equals, 42. You're going to have something like this. So, and I'll get into all these concepts later. You're not going to have time to do this trial and error, right? You're going to have to use some sort of method, right? Formulas, theorems that have been proven, so then you can solve these quick, right? So, but this was a fairly simple one, so you could do trial and error. But in the grand scheme of things, you're going to be using all the tools at your disposal. But again, just think of this as a mystery. You're trying to solve the mystery of, well, what is causing, this, how are you getting this value, right? And so that's what I want you to think about as we go through. And so again, we use these letters, right, because they're variables. So this x, y, z, and believe it or not, some of these variables, can have different meanings, right? So when you start getting into calculus and all that, you might come up with you might say variable c, right? So you want to be careful because c stands for constant. And so you don't want to say c plus 2 equals 3 because people will be really confused because there's a standard meaning of c. So we tend to stick to these x, y, z variables, and then there are a couple of variables, but because it's an introduction, just keep these in mind, right? And so if you have several unknowns, you can have like this: 3x plus 4y equals 6z. You can have that. And again, I'm getting ahead of myself, but that's why we use these variables. They're much easier to do, much easier to keep track of. So what we want to know is, let's get back to our other example, which is, x minus, I believe it was 2 equals 1. Well, I showed you trial and error, right? Trial and error. So that doesn't work. So now, we need to use our basic math skills to figure out how to solve this. So first of all, what we want to do is we want to leave this x alone. So at the end of the day, what we want to do is we want to find what x equals, right? We don't know that yet. So how do we do that? Well, what we do to one side, right, we do to the other side in essence, right? And actually, let me fix this because that's a little bit different. That's a little bit different, that notation. So again, what we do to one variable, one number on this side, we have to do to another variable on this side. So what do we need to do to get rid of this 2? All right, so let's say it's coming out from here. So we do x minus 2 is equal to 1. So if we add 2 to both sides, right, we've just created an equation, and so this is equal to x, this is equal to 0, so plus 0, and this is equal to 3. Well, we don't really need to say plus 0, so we have x equal to 3. So, why did we add 2 to both sides? Well, you're trying to maintain the integrity, the balance of your equation. So if you add 2 to one side, you add 2 to another side. If you add 1 to this side, add 1 to another side. So even if we didn't finish solving this, right, even if we said x minus 2 equal to 1, well, we weren't sure, so we can still add 1 to both sides, right? But then we have now x minus 1 is equal to 2, and then we'll just say add 1 again. Plus 1, excuse me, plus, pen's acting weird. Let's fix this up a little bit. So x plus 1. Oh, whoops, we don't need this. Whoops. So then this is x plus 0 equals 3. So we still get the same thing. And sometimes you may have to do this extra step because you may not be sure, you may have forgotten something, but you still arrive at the same answer. It just took a bit longer, and that's okay. So again, what we've just shown you was simple keeping balance of the equations from one side to the right side. So this is as basic as it gets for the algebra. Now, in the next few lessons, we'll begin a little bit more complicated. But so here's some examples. So if we did x plus 4 equals 6, right? And then x plus minus 3 is equal to 2. So how would we This is a 6. Hold on there. Okay, I had to fix that 6 for a minute there. It wasn't looking right. So x plus 4 equals 6. So how do we solve this? Well, x minus 4 is equal to 4, right? Wait, we don't need this. Excuse me. So minus 4, so x plus 0 equals 2. So x equals 2. So let's see that I don't mess this up. So plus 3, okay, equals plus 3. So x plus 0 equals 5. X equals 5, right? Now, what always confuses students, I notice, is when we deal with one variable, we're always dealing with x. But if I throw something, they're always used to seeing, x plus blank equals that. But if I do something different, like z minus 3 equals 4, or if I do 3 minus z equals 1. Okay, so this here might actually trick people, right? Because they're used to seeing, let's fix this. Right, because they're used to seeing the x. But let's just see here. This is the same as a variable, so it's just a variable, right? Var, right? So same thing. Add 3. So z plus 0 equals 7. So z equals 7, right? So nothing really changed, except I decided to use a z instead of an x. I could have used y as well. Well, now this is a bit tricky, right? Because some people will get used to saying positive z, but it's the same thing. So let's just see what we can do. Well, we can do this. So we keep this as a 3. We can add z plus z, right? And then we could say equals 1 plus z, right? So now we have 3 equals 1 plus z. And then, it's the same format as before. Subtract 1, subtract 1. So essentially, let me just bring it up here. 2 equals z. Or if you're used to seeing it in the formal way we've done it, z equals 2. Right, and you could just plug that in. So 3 minus 2 equals 1, right? So 1 equals 1. So it checks out. So, these are the basics of algebra. So I hope that made a lot of sense. So next we're going to get into exponents, which that'll be a little bit tricky, but you should be able to understand it.